Hey everybody, we have a cubic polynomial with an unknown coefficient. That coefficient is the coefficient in the quadratic term. We're given that two of the unknown roots have a product of 10. And so I'm going to write that down right here. AB is equal to 10. Okay, y'all, that's supposed to be the product AB right there. Let me erase that real quick. That's the product AB, and A and B are a pair of the roots. All right. So that's really the only thing that's given as far as the instructions. We are given the linear coefficient and the constant coefficient, but we're supposed to find the value of S. Okay, and y'all remember a root is any value of x that makes the polynomial vanish, i.e. the polynomial is equal to 0 when you substitute that value in for x. All right. Now what we're doing here, since we're given that A, B, and C are the roots, and it's not really important about the distinct, I don't think. They probably don't have to be distinct. But we're going to let A, B, and C be the roots, and here's the expansion. Okay, so we have x minus A times x minus B times x minus C, and I forgot to put equals 0 here. Now I did a lot of the work here just to save time. When you expand this out, you get a cubic term with the coefficient of 1. This is a monic cubic. All right, and then you have minus the sum of the roots in front of x squared, and this happens when you just expand this out. The minus a, the minus b, and the minus c appear connected or next to the x squared term. And again, you can see that if you expand this out. I didn't show all the work. And also the product, the sum of the product of each of the roots appears as the coefficient of the x term, and finally the negative product of the roots appears the constant term. Okay, so the rest of this is just about equating coefficients. This has a name, it's called Vietas, but you can just do this. If you don't remember Vietas, you can expand it out yourself and just see what's going on. Okay, so notice that 92 over 5 is the coefficient of the x term, so that's why we equate it to AB plus AC plus AB, but we know that AB is 10, right? Now we could have picked any of them. The algebra would have worked out the same. We could have picked AC to be equal to 10 or BC to be equal to 10. I just arbitrarily picked AB. Now, so when you subtract 10 from both sides, you get 42 over 5 equals to AC plus BC. So perhaps a little bit of progress has been made. Now also right here, minus 14 is the constant term. We equate it with minus ABC. The minus signs go away, and you get 14 is equal to 10C. If you divide through by 10, this is the same thing as saying C is equal to 7/5. 14 over 10 reduces to 7 over 5. 14 and 10 have a common factor of 2. Okay. Okay, so we already know one of the zeros, not that we're trying to find that, we're trying to find S, okay, which I don't think it's possible to find all the zeros, but we found one of them here in the process. Okay, now S, here's S, x squared, and then here's minus a plus b plus c x squared, so we can equate S with the negative sum of the roots. All right, now c is equal to 7/5 as we've seen, but notice that right up here we can write this as c times a plus b. Factor a c out and we have c times a plus b. Okay, and that's equal to 42 over 5. But notice what happens here. Let's just fill it in right here. We would have negative, okay, minus. Now let's write down exactly what we have here. Okay, a plus b, if you divide through by c here, you would get 42 over 5 over c is equal to a plus b. But that we already know that c is 7 over 5, right? So we can write 42 over 5. Let's be careful. 42 over 5. 42 divided by 5 divided by 7. Okay, folks, like that, and then plus 7/5 here. And y'all, let's make sure I didn't make any mistakes here. Okay, now let's look. Wait, what do we have here? This is 42 over 5, and this would be 7 over 5 here too. Sorry. Okay. Yeah. Again, let's double check the arithmetic here. A plus B would be equal to 42 over 5 divided by C, but C is known to be 7/5, right? Okay. Now we already have 7/5 sitting right here, and so what happens here? Well, when we divide by the 7/5 here, that's the same as inverting and multiplying, right? So the 5s would cancel, and this would just end up being negative negative 6 right here plus 7/5. All right, folks, and again, not too hard to, this looks rather messy, but again, when you divide by a fraction, it's the same as inverting and multiplying, so the 5s would cancel, and you'd have 42 over 7, which is the 6 you see right here. And notice that this is equal to negative, this would be 6 over 6 is the same as 30, right, over 5. 6 is equal to 30 over 5. So we would have minus, and I'll use the parentheses here just maybe for the sake of readability, is equal to S. Okay. Remember, all of this stuff is just equal to S. So this is our answer. S is equal to minus, the parentheses unnecessary, of course. S is equal to minus 37 over 5. So let me come up here and write that down at the end. S is equal to minus 37 over 5. Now, there's other questions I could have asked. It turns out the sum of the roots, you see, you can see by the way this is set up that the sum of the roots is negative the sum of the zeros, right? So in other words, we would have minus 37 over 5 right here is equal to minus the sum of the zeros. So the sum of the zeros of this original polynomial is actually positive 37 over 5. But we were trying to find the value of S. And y'all, I'm not even sure if you can find, I don't think you can, I'm not sure if you can find each of the 3 zeros. We've found one of them, but I don't know how to find the other 2 really from this information, but I sure know that their negative sum is minus 37 over 5 right here. So there's your solution. Let me know what you thought. And again, I think there's a lot of variations on this kind of problem that could be presented, but this one was the first one that came to mind. Thank you for viewing.